everybody. This is just a quick video to work through questions 8 and 9 from our last quiz 6. I'm sorry, it's not 8 and 9, it's 8 and 10. But most people got number 9. Maybe I'll hit all three of them. What the heck? So the first question, number 8, is about one of these Leontief models for an economy. Now, what you need to understand, I think, in this setup is what these numbers represent. They think of them as percentages, although written as decimals between 0 and 1. But they're, the thing in position 1, is the percent of the output from the first section of the economy that's going to the first section of the economy. In fact, this 0.45, that's the output from that first section of the economy that's going to the second section of the economy. And if you look at these three numbers, notice that they add up to 100% or 1. This means that all of the output from the first section of the economy is getting used up by these three economic sections. That is, there's nothing left for somebody else outside of the system. That makes this a closed system. Well, not just that, but notice that these numbers all add up to 1 as well, and also those numbers all add up to 1. So what we've got here is all of the output from each section of the economy is being used up within these three sections. Nothing else is left over, and nothing else is coming in from outside of those three sections. That's closure, right? You've just got a tight little, like a village with 3 people in it, and no outside communication. All right, so how do we solve such a problem? What you're going to need to do is create the matrix I minus A. So that's an identity matrix minus the matrix A, and analyze with that. Now there's a big, I don't know, there's a whole explanation of that, but I just sort of want to hit the nuts and bolts here today. You can look for the explanation of why you look at the identity minus A in the readings for this section. But anyway, if you want to create I minus A, find the best way to do it is to get onto GeoGebra and use the algebra tool. So I'm going to make A be the matrix. Oh, come to think of it, I'm going to need to see the numbers at the same time. So let me just pull away the, yeah, that works, right? We can see both things. So inside it, we got to go a little farther over. Oh, it's trying to make it go. Okay, and there, I can see the numbers and edit the matrix at the same time. Cool. So our first row has a 0.15, a 0.04, and a 0.32. Whoops, that's the first row. So the format of these things is use curly braces around the items in the thing, and the items in this matrix are the rows in the matrix. So that's the right kind of format. So I've got a matrix right now with just a single row in it, but I'm going to put in another row. And that second row has 0.45, whoops, need a comma there, 0.39, and 0.18. Just occurs to me, if I made this font a little bigger, it'd probably be better for you guys. All right. And the last row is 0.4. Well, got to put the parentheses around it. 0.4, 0.57, and 0.5. I hit go in that, and here's something I did want to mention to people. The once you've defined a matrix, it does this pretty version of it, and now it's not easy to edit it. You can click in there and edit numbers, but for instance, if you wanted to add another number, I'm not sure how to do that. So a little piece of GeoGebra, I don't know, extra information is this. Go ahead and select the item and come over to the gear and get the settings for that item. And I mean the settings for this item. You see the definition of the matrix is right in there. So if I wanted to add more stuff to it, I could do that now. I could go in and edit this definition, and it would be reflected up there. Right here, I'll just give you an example. Change that last one to a 0.6. And you see how this one became 0.6. Of course, I don't really want that. I want it to be 0.5 like the matrix in the problem was. Okay. So let me just kill that window and get us back to looking at the algebra view. Now, I did say we wanted to have the identity matrix minus A. So I believe the best way to do that is to just use the computer. A lot of people are doing this aspect by hand, but you can get an identity matrix in GeoGebra by typing identity and then tell it how big you want it to be. That's right. Well, actually, come to think of it, what we want is the identity matrix minus A. So let's just go and do that all in one step. There you go. That matrix with some numbers positive, some numbers negative, is the thing we want to know about. All right. Well, how do we solve the system? We just want the reduced row echelon form of that thing. And again, that's something that GeoGebra will do for us. Something happened here where I accidentally put in something I didn't want, so let me delete that. The matrix we want to take the reduced row echelon form is B there. And it's an identity matrix. It's not supposed to be. There's supposed to be a free variable. This probably means I did something wrong. Yeah, I can see that I did something wrong. Okay, so I wonder if you guys see what I did wrong. When I put in the very first entry, I thought I typed 0.15, but apparently only 0.1 came in. But if you just look through the entries, and I usually enter the things by going across the rows and then check them by going down the columns. And so this entry is incorrect. 04, 39, 57, those are right. 32, 18, and 5, those are right. Okay, so cool. Let's do what I said before about changing the definition of this matrix. Yep, it needed a 0.15 there. Now that automatically, by the way, did you see everything else updated when I did that? The B matrix is changed now. See how it's got a 0.85 in the 1-1 position, and its reduced row echelon form is the sort we want. Now let's see. I need to explain something about how we need to use this reduced row echelon form, because honestly, what we really want is I minus A with an augmented column that's got zeros in it. That's the matrix for the system. That bar stands for the equal sign, and these zeros are the things on the right-hand side. So let me just interpret the way that reduced row echelon form looks in terms of equations. The bottom row with all zeros is just telling you that the variable that's corresponding to the third column is completely free. Okay, well that means R is just R. You know, that they did tell us in the problem to use R as the variable. But like, look at the top row of the matrix here. It's saying 1 times x plus 0 times y minus 0.404 times r, because that third column corresponds to the variable r, equals, well, the 0 that I'm imagining in the augmented column. All right, so we have x minus 0.404 r equals 0. Well, what does that say about what x is equal to, you just add that part to both sides, and you get x is equal to 0.404r. Okay. There's a temptation people have to copy all of those numbers, 0.4043956. Oh, it's silly. Don't do that. You see how the input data had 2 decimal places, 2 significant figures? You should only have 2, maybe 3 significant figures in the output. That said, I have noticed that sometimes when you do this problem and you don't give it 3 or 4 digits, it marks a correct answer wrong. So if you get something that you're pretty sure is right and it said it's wrong, try adding a few more decimal places, and that it shouldn't be that way. But I'll have to dig into the code for the my open math problem and see if we can fix that. So it should accept rounded to 2 decimal places. That would be fine. Okay, so we've got x is 0.404. Similarly, you can probably see from that y is going to be 0.593 times r. Let's actually see if I did it right. Yeah, so what did I say? X was 0.404 times r. Notice they give us a button to push for r. Y is 0.593 times r. And then, well, z is just r. See how I like that? So that's the process. Use GeoGebra to create the matrix I minus A. There should be some smart way to add a column of zeros to it, but I can just imagine the zeros there, so we don't need to worry about getting the augmented matrix. And then row reduce it, and the rows of the reduced matrix interpreted as equations tell us how to express x and y, well, and in a sense z as well, in terms of our free variable. Okay, so that's just going through solving a Leontief model. Like I said, almost everybody got this one right, but it's kind of fun to do it. All you're expected to do for this is to increase the slider for m until the last possible moment before you leave the feasible region, which seems to be about right there. Now, the slider says 139.9, but we're clearly on the point 14.4. And what does our objective do? 8x plus 7y to 14.4. It's actually 140. So for this one, 140 is your answer. Did it like that? Oh, I have to hit check answer. Cool. Now, this one is the hairy guy that was problematic for a lot of folks. So I'm going to fully treat that. I'm going to solve this using GeoGebra and graphing, but you could set up a simplex tableau and solve it that way too. I just think that that's a bit overkill because this is a 2-variable problem. There's just well, what are the variables? They're usually going to be called x and y. In this one, they end up being the amount of, well, say x is the amount of the dairy-based meal meal option that we've got, and y is the amount of the vegan option. Let me just go through the question here and record the things that are important for us. So, first of all, it's annoying to me that the things in here are all beginning with the letter C. We've got to have 2,400 milligrams of vitamin C. We have to have 18 milligrams of calcium, and we have to have 1,200 calories. Those are all inequalities, but I would love to use variables that represented the things, and that's tough to do when they're all beginning with the letter C. So how about if I use V site for, well, I've got the worst pen ever. We got to do it. 2 in a row. Let's see if there's a third time's the charm. V is equal to the number of I guess it's milligrams of vitamin C. Let's go ahead and use C for the calcium. So there'll be number of milligrams of calcium. Oh, spelling issues. And then we need to have another variable for calories. So how about Q? I don't know what to do. Q is the number of calories. Okay, and it tells us some facts about these things. We want that V is greater than or equal to 2400. C, the calcium is greater than or equal to 1800. And Q, the amount of calories, is at least 1200. A typical adult needs about 2,000 calories. So this is, I gotta mention, that's a pretty like a starvation diet. If you were trying to rapidly lose weight, you might try to restrict your calories to 1,200. Also, 2,400 milligrams of vitamin C is an awful lot. 2.4 grams of vitamin C is like probably 50 times as much as a normal diet would contain. But anyway, these numbers are just there to this is common in math problems. They're there to like give us something where the numerics work out fairly easy. Okay, now we have these two food types to use in constructing this diet. We've got the dairy-based, which I'm going to call X. And now the dairy-based stuff and the vegan option talk about how much they give per ounce. So X is the number of ounces of dairy-based. And Y is going to be the number of ounces of the vegan option. Just occurred to me I'm sort of using the screen real estate poorly here. Let's get that over there and whoops. There it is. Maybe we can even make this document cam view a little bigger. Apparently is as big as I can go because it just is adding black to the sides of it. All right, so great. What about these inequalities? We said V, the vitamin C content, had to be at least 2,400. Well, the vitamin C that you get comes from the two foods. So the amount of C is going to be however much is in an ounce of the dairy meal times how many ounces, plus however much is in the vegan meal times how many ounces of that. And the statement of the problem gave us information about that. I do need to keep everything visible. So, all right. So let's see. Each ounce of the dairy-based meal provides 50 milligrams of vitamin C. So the vitamin C content is 50 times X. That's the dairy-based stuff, or the contribution of the dairy-based stuff to your vitamin C content. Each ounce of the vegan stuff gives you 20 milligrams. So 20 times Y. That's your vitamin C content. And I called it C. That's V. That's what you called it before. What about the thing that actually is C, the calcium? Well, how much calcium do we get from the dairy-based meal? I see it in there. There's a whole lot of numbers in here, and it's easy to lose track of them all. But that's the one that tells you each ounce of the dairy-based meal provides 30 milligrams of calcium. Hey, while we're here, how much calcium does the vegan thing give us? Nope. I was thinking I could highlight them separately. No, I can't. Anyways, 30 and 20. So C is 30x plus 20y. And finally, the calories, I called that Q before. Well, how much is in the dairy-based? 10 calories. And how much is in the vegan? 40 calories. I have to just point out here that that's silly. Just, because dairy is a really calorie-rich kind of food. When you have things like cheese and milk, that's full of calories and full of calcium too. And well, they do say the calcium is a little more than the vegan, but having the vegan provide this 40 calories is tough because no animal products at all in vegan food. It's hard to get a lot of calories out of just grains and fruits and things. Anyway, so then this is good because we're going to basically get an inequality out of each of these things we've collected. We'll have this combination of x and y has got to be greater than the 2400, and then this combination of x and y will have to be greater than the 1800, and finally the calories, 10x plus 40y, that's going to have to be greater than the 1200. All right. So yay. Bunch of inequalities, and those will determine our feasible region. The other element we need is the objective function. What are we trying to minimize or maximize? And in this one, it's cost of these meals. Now, this is actually also worthy of comment. They're saying the dairy-based meals cost 59 cents per ounce, and the vegan meals cost 21 cents per ounce, and that's backwards as well. The dairy-based meal would be cheaper per ounce than the vegan would. Vegan food is generally kind of expensive, unless you prepare it on your own. If you make your own stuff, you can be pretty frugal about eating a vegan diet. Anyway, so what does that make our objective function? Well, it's just, let's call it F, is the 59.9 cents per ounce. Let's do it in dollars. So 0.599 times X plus the amount of the vegan, the cost of the vegan is 0.211 times Y. All right, so we have three inequalities determining a feasible region, and that is the objective function. I'm going to try to keep that down in the corner of the screen, and we'll go to GeoGebra to plot things and solve this for us. I guess I kind of don't need all those matrices now, but let's leave them. Okay, so the first thing I'm going to plot is the vitamin C inequality, which says 50x plus 20y is greater than or equal to 2400. I guess it would be kind of nice to be able to see that while we're typing it. And I'd also honestly like to be able to see it in the graphics window. So I'm going to expand this. Oh, you know what? I'm just going to have to shrink the font again so that we get a little bit of a view of the graphics window. Well, the graphics window is blank. What's the issue with that? This inequality involves a pretty big number on the right-hand side, so my guess is that we just need to zoom way out. Way out? Oh, not too crazy far out. All right. So there's our first inequality. What's our second inequality going to be? 30x plus 20y, and then that's greater than or equal to 1800. Oh, that's nice. We've got two overlapping regions. Sometimes I like to color these things differently, but I think I'm just going to live with that. They're all the same color. And then the last inequality comes from the calories. That's 10x plus 40y, and that has to be at least 1200, isn't it? Oops. We got something formatting issue wrong. Greater than or equal to, there we go, 1200. Okay, you can see what the feasible region is now. It's the stuff that's colored in the darkest. It's the intersection of all three of these regions. So the overlap of all three of them. It's got a corner that's visible there and another corner that's visible there. It's an infinite region, and that's because this is a minimization problem. We're looking for the smallest value of our objective function. So that'll be closest into the origin, and this region doesn't go all the way to the origin, so that's kind of good. Let's add in a plot of our objective function, 0.599x plus 0.211y. Actually, I think I want to name it f of x and y equals that. And then we want to see something on a plot, so f of x and y set equal to a variable k, and we'll get a slider for k. I wanted a slider for k. I don't know what to use for all these variables for the slider, but let's just leave the rest of those at their defaults and see what we get. All right, you know what? I'm sorry. Rather than messing around with GeoGebra's interface, let me just do this the brute force way. 0.599x plus 0.211y equals k. Oh, I see. The slider's up here. Darn it. So it's in there. It's just that the k is already set to 1. Didn't see, it wasn't turned on, so you couldn't see it on the screen. There we go. Okay, so there's our objective function, and if we move the slider around, we'll move where that line appears, but we don't change its slope. Notice that's important. I don't seem to be going far enough in the positive direction, so I'm going to move it up to maybe 80 as the upper limit. Didn't do anything. Oh, I changed the step to 80. Keep the step at 1, make the upper limit 80. Alright, so now we should be able to slide that slider up until, where do we want to be? We want to be in the feasible region, but as far out of it as we can get. Now, that would appear, you see that it looks like, I should also mention this. The other thing that we have is a positivity condition on all the variables. X is, the smallest x can be is 0. Now if x is 0, y would be 120, and we would still be in the feasible region. So with this particular slope, we don't hit this corner, we don't hit this corner, we don't hit that corner. We get that one up there. That's x is 0, y is 120. And you see that, pretty straightforwardly from the graph. That it's funny. Oh, I did this previously, and it did turn out to be the answer was one of these points. And I just realized the problem gives us randomized, the computer gives us randomized questions. So you've got 4 different spots on this feasible region. There probably could be any one of the 4. So not everybody is going to get the same answer. But if we're at that location, x is 0 and y is 120, what is our value of the objective function? We just need to know what is 211 times 120. 25.32. So let's, or have I lost it? Where is the GeoGebra question? So we got none of the dairy-based, 100% vegan, which was 120 ounces. That's worth commenting on too, isn't it? I think that's many pounds of food. That's like a lot of food. Anyway, it is what it is. And what did I just get for the value? $25 for the $25.32. Let's see if we get all these. Yay, we got them all. 0, 120. Yeah, this is the advantage of being the teacher. You get to see the answers that's given. Cool. All right, so that's gonna be it for this quick little video. I hope it is of some use to you guys in sort of showing you the nuts and bolts of solving these simplex problems. When you can do them graphically, that's really easy. And honestly, we're not going to do. You will see simplex tableaus that you need to set up that might have 3 or 4 variables, but trying to actually solve such a problem, it's sort of beyond the scope of this course. What you do is you just turn it over to a simplex solver, a computer program that solves those things. So you don't need to know that. But one of these graphical problems involving just 2 variables, that could easily be on the final. So I want you to be prepared for that. All right, have a great day and good luck tomorrow on the final exam.